Well, so I'm Cedric Owens, and I'll be talking about post-infection analysis as well as some simple things you can do to kind of jumpstart some detections for macOS hosts in your environment. So a little bit about myself. I'm actually on the red team at Box currently. I've been doing red team now for about 3 years, but I actually come from a blue team background, so go blue team. I actually am passionate about defenses and detection, so even in my red team role, I really enjoy collaborating with Blue Team and kind of sharing like the latest techniques that I've been seeing that I'm trying, and also kind of learning about newest defensive techniques and kind of helping each other get better in that space. Based here out of Austin, and I'd say a big interest of mine is post-exploitation for macOS. I've actually written a couple post-exploitation tools just to understand how it works under the hood, what detection challenges are and limitations are. So that's a big interest of mine, and kind of feeding into this talk. I thought it would be good to share from an offensive perspective kind of what some low-hanging fruit common attack techniques are and how easily detectable some of those are, and some things you can look for in your environments. So I hope you guys find it useful. So in terms of agenda, I plan to start off talking about the state of the union through my eyes for macOS, kind of where we are, some challenges there. As I mentioned, being able to, some simple things you can do to jumpstart or get going with a detection program for macOS. Useful macOS artifacts, so in the event that you do have an infected Mac machine in your environment, some places you can look, things you can key in on to help start, I guess, peeling the layers of the onion back. Also, some tools that actually automate collection once you have an infected Mac. So the post-infection side, I'm kind of looking at it more of, let's say you have no EDR and you've just bare bones, like how could you do post-infection analysis? And I know a lot of organizations, we have EDR, endpoint detection and response, but I think it still might be useful to understand kind of how to do it without relying on the tools, or at least understanding what the EDR is doing behind the hood, how it's or under the hood, how it's working. So in terms of state of the union for macOS, most of the world, macOS is still in a minority. So you can see here from the statistics, Windows is still the lion's share for desktop operating systems, but macOS has been growing. And what's interesting is in Bay Area companies, like I currently work at Box, which is headquartered in the Bay, tech company, it's kind of the flip. You actually see more macOS endpoints and less Windows. So for me, that was an interesting challenge, and one of the reasons I wanted to go work in the Bay, because I was so used to Windows, and I really wanted to throw myself in an environment that I was not familiar with and see like how can I tackle this problem of attacking macOS as well as defending macOS hosts. And so I think there's a growing need for analysts that can understand like how macOS works and what to look for, because I only think that percentage is going to grow, right? Even in Windows companies, there are, it's like a growing trend. You guys can hear. Can you guys hear? Sorry about that. Oh, okay. Can you hear me? Test. Yeah. Hello? All right, I'll shout for now. So there's a growing need for macOS analysts is what I was basically hinting to, because even in large organizations that are Windows shops, you're starting to see VIP users like executives or even admins with a lot of access being segmented over to Mac as an additional layer of protection. So as it relates to macOS incident response, for the most part, like there's a lot of discomfort with it because most malware has been Windows, right? Malware follows the largest market share, so there's a lot of questions around how do you do incident response in macOS? Like what does persistence look like? What kind of payload should I be concerned about? How do I know when it's clean? How do I know adware versus malware? It's a lot of questions, so I hope this presentation can help on some of those areas for you. So first, before I jump into post-infection analysis, I'll start talking about some simple detections or searches you can do in your environment to find some hopefully high-fidelity searches to help you find some malicious or suspicious activity. The first area being parent-child relationships. So the first one I'll mention is kind of rooted in understanding how post-exploitation works on a lot of kits that target macOS. Up to this point, most post-exploitation kits for macOS have been Python-based. Several reasons for that. Python is very well supported, lots of libraries for it. Secondly, Python allows you to get around Gatekeeper because up to this point, Gatekeeper has only been checking macOS binaries, so macOS, app packages, kernel extensions, installers, and pretty much ignoring Python. So it's been a popular avenue up to this point. So one thing you could do to start getting a feel for suspicious activities is building a search around parent-child relationships where you have Python that spawns a shell environment, which then in turn launches a process on disk. The reason I was able to find this out is because I went down the path of writing post-exploitation tool myself that was Python-based so I could understand how it worked. And what happens is, like if I had a macro, the user clicked enable, Python's running, talking to a C2 server, and when it gets a command, what happens is it spawns binsh by default. You can change it to bin bash, and then it actually runs that command. So that's an interesting parent-child relationship hierarchy, if you will, that you could key in on. Another one would be Office products that spawn binsh or bin bash. So kind of similar concept there as well. For macOS, the macros that I've used on the red team side, what happens is the user opens the document, they're prompted, and if they click enable, then binsh is called, which then calls Python. So kind of similar concept to the last, but another helpful parent-child flow that you could key in on. Another one, Microsoft Office product spawning OSA script. So a little bit about OSA script. It's an open scripting architecture. It allows you to easily run Apple script or JavaScript on your macOS host. And so it can do everything from getting clipboard contents to prompting the user with a fake pop-up, all sorts of really cool stuff that you can do very easily with OSA script. So to me, OSA script is one of those things you want to monitor. If you just key in on OSA script, you'll get a lot of false positives because a lot of people do use it most likely for automation. So there's some things you might want to add to it, such as a parent process of Microsoft Office, which in my mind, very few cases, if at all, that you should see in your environment. Another one, MS Office spawning curl. So in the aforementioned example, let's say I have an Office macro that uses OSA script. It prompts the user, hey, this document's encrypted, enter your Apple ID and password as an example. And then after they enter that, I take those as variables and I curl them out to the server. So that would be another aspect of a parent-child relationship that you could key in on. And so here's an example of the macro itself. This macro came from a tool called MacFish that's available out on GitHub. And it does the exact example that I mentioned. You can see Mac script do shell script, which is basically telling Apple script on the Mac host to run the OSA script binary, and then it says display dialog, or in other words, do a pop-up. And then you can put whatever text you want. So in this case, it's saying, like, we need your Apple ID and password to decrypt this secure file. The results are stored in a variable. They're split, so you know which one is the username, which one is the password, and then you can curl it out, use curl to send it out to a C2 server. So that's a simple example on the macOS side of how, one of the reasons why you might want to watch some of the aforementioned parent-child relationships. And then next area, Python spawning OSA script. So valid use of OSA script that I've seen, typically the user runs it like from a .scpt file, Apple script file, or directly in the terminal. Very rarely see someone using Python to actually launch OSA script. So that's something, again, you can key on because a lot of post-exploitation has been Python-based up to this point. So that's something you could look at. So next area that you could key in on are some common Active Directory searches. So assuming you have Mac hosts in your environment that are joined to AD, these are some things you could look at as well. So first example, DSCL, Directory Services Command Line Utility. So it's a pretty cool built-in binary for macOS that allows you to interact with Active Directory, very similar to some of the Windows utilities. Not as thorough or as verbose, but pretty similar in terms of the types of queries you can run. So in this case, if you run dscl Active Directory with your domain, and then you do ls like /computers or ls-users or -groups, what that then provides you with is you're able to download dumps of AD data. So at the bottom will give you, that example at the bottom will give you a dump of all Active Directory computers. So it might be something of interest for you in your environment to see who's querying Active Directory, what parent process is doing it through, things of that nature. Another use for Directory Services command line utility is looking for users actually that are on the system itself. So a very simple way to enumerate users on the host is command in number 2. Number 3, a simple way to look for users that have admin rights on the Mac host as well. So not the only ways of doing it, but just common ways. And really what I'm hoping to do is just kind of evoke your thought process of like things attackers might look for. There's always various ways you can get there. Another one, dsconfig AD, another helpful utility built into macOS, but it's very similar. I guess one use I've seen out of it from a red team perspective is it shows what AD groups have local admin rights on your Mac. So if like domain admins or enterprise admins have access on your Mac, you can see that, or desktop admins, things like that. And it's also a useful utility that you can run to see if a Mac is joined to the domain, because if you run this and you get no results back, then you can conclude that this Mac's not joined to the domain. Another one, klist. So on the Kerberos side, if there's any Kerberos cache files on disk that have been dumped, you can use klist to start listing cached Kerberos tickets, which you could use at some point for Kerberosing or pass the ticket. So that would be something you could search for as well. I would imagine that you would not see a lot of activity in your environment, valid activity using klist, so that's something you could look for. For local account enumeration, you could also use the dscache util with the group ID of 80. So this would be an example showing what users, another way that I mentioned earlier, how you can find what users have local admin on your Mac. So third area, some additional command line searches or detections. So I do want to caveat, I don't think command line detections are strong enough that you can build all your program off of it, but I do think it's a helpful layer, right? Command line detections will still get some low-hanging fruit in your environment, so I still think there's use of it as just one of several different layers. So going back to OSA script, if you're looking, one of the interesting uses for me for OSA script is you feed it -L, which is the language parameter in JavaScript. So talking about this here, the background of why it's useful, AppleScript for the longest on macOS has been the preferred way to do automation. But recently, one thing about AppleScript, if you have a very complex piece of automation you're doing, the syntax gets ugly really fast. And it gets hard to keep up with what syntax should go where. So one of the reasons I think they decided at Apple to move to JXA, which is JavaScript for automation, is it's very simple in its syntax and allows you to do some complex things relatively easy. And so one reason I thought that this was useful is because now there's a tool out called AppFell that you guys might have heard of. A guy at SpectreOps, Cody Thomas, wrote it. And what it is it allows you to use JXA, JavaScript for automation, for malicious purposes. So what happens is the server is in JavaScript, and there's now a bridge between JavaScript and Objective-C. So the server's in JavaScript, but it's importing Objective-C, and then your post-exploitation code is in Objective-C. So just by running on the target host, OSA script -L JavaScript, and then an eval statement, you can now, it's another way now to actually have post-exploitation on your Mac OS. And one interesting thing about that too is I was doing some notarization testing, and a lot of payloads for Mac OS get around, like Apple actually would notarize it and send it back. Because a lot of the code is on the server side instead of in the client binary. So that was a pretty interesting observation for me. Another use for OSA script that you may want to look at is sending or watching OSA script with -E and password or credentials or creds, any of those variations. And the reason why is because it's a good chance that your users might be getting prompted to enter credentials. The reason I was familiar with this is because this is the way I use in one of my post-exploitation toolkits that I wrote, where it was a prompt command that I would enter on the operator side, and then on the client side, that terminal window down there is the command that it would actually run. It would run OSA script, prompt the user to enter credentials, and then you can see at the bottom, whatever text they enter and they click enter or click OK, it's returned back to the server. So that would be a useful search as well. OSA script with E and clipboard. That's a method I've used to actually dump clipboard contents on macOS. Super easy, high fidelity, something you may want to look for. Another idea I had that we've gotten mileage out of at Box, which is using Pen Test Monkey's reverse shell scripts. So it's a really helpful site, and it's got the syntax for various types of reverse shells, all the way from Bash to Perl, Python. So it's a really, to me, it's a quick win to just take those and just make sure you have some kind of command line detection coverage for those. Next one, screen capture -X. Again, I've used this to get a screenshot. So screen capture is the native macOS binary for getting a screenshot, and -X tells it to do it quietly, like don't make the Apple clicking sound. So to me, if I were to see this in my environment, like someone trying to quietly get a screenshot, it would definitely raise suspicions. Another one is the extended attributes, like someone attempting to remove extended attributes. So a little bit about this. For macOS, the operating system itself, the way it currently works is if any files that are downloaded through a browser or through email, they get extended attributes added to them. One of those extended attributes is the com.apple.quarantine attribute, which most people call the quarantine flag. And so based on the file type, when a user goes to run that file, if it's like a macOS executable file like a Maco, an app package, then Gatekeeper sees it has that quarantine, and then it will check out to Apple to see if it's signed with a valid developer cert. And for future versions of macOS, it now checks to see if that file has been notarized. So what Apple is now requiring people to do is to actually send your binary to Apple. It goes through their scanner engines, and then if it passes, it's like a notarization receipt that's attached to your binary. So long story short, this would be a method that could be used to try to get around that and just remove the quarantine attribute itself, because Gatekeeper, from an offensive perspective, Gatekeeper can be a pain at times. Another one from the command line, launch CTL load. So this is a way to load a plist for persistence. So common methods for persistence on macOS are typically launch agents and launch daemons. Patrick Wardle's Mac Malware of 2019 report, where he highlighted different samples that they actually saw in the wild, pointed to that. Like most of the persistence there was using launch agents and launch daemons. So that's one common way that those are loaded for persistence. So next, I'll pivot to a couple other ideas for useful detections, and then we'll move on to post-infection analysis. One, single parent Python process making lots of outbound network connections. So again, host-based logs. You see one Python and it's just one PID, and then over time it just keeps connecting out. That would be interesting. An app package making prolonged network connections. Again, host-based visibility. Network-based visibility, a single macOS host connecting out, like sort of a beaconing frequency, like every 30 seconds or every minute or so to a similar destination host or port. Those would be useful as well. Another one, unique user agent strings, and I know that it may seem kind of old school or not very useful, but malware still does use unique user agent strings. Someone earlier talked about an example, and even in Patrick Wardle's Mac Malware 2019 report, there were some samples in there that had unique user agents. So even though it may seem antiquated, there's still value in that, like looking for least common user agents in your environment and kind of pulling the thread and seeing what's there. So now pivoting, let's say you now you have a machine that you suspect to be infected. What places can you look on the system to get more data? So that's what this next section is. So in terms of the brains behind the common technique that's been used for post-infection analysis on macOS, Thomas Reed has been really driving that thought process and techniques. He's like the director of malware analysis at Malwarebytes, and he's been focusing on Mac for years before Mac was even popular. And he's done some really cool stuff. One of the things he did is he wrote the PICT tool, Post-Infection Collection Toolkit, and the stuff you'll see later on the slides of different artifacts. It actually goes out and grabs those, zips them up for you so you can take them offline and do analysis. So I took his PICT tool, which his tool is in Python. I ported it over to Swift because Swift is one of the native tools for macOS, and then added an additional search to it. So a link to my tool, PICT Swift, is there as well. So some of the areas that the PICT tools grabs. Browser history, so quarantine events v2 database. I talked a little bit earlier about how the macOS operating system adds a quarantine attribute to files that are downloaded. And not only does it add the attribute, it logs it in the database. So that's a good history for you to pull from, as well as your browser histories. Safari, Chrome, Firefox, they're all SQLite databases that you can query and parse. So I also wrote a Mako binary just to show or to help parse the quarantine events as well as your browser history files, and that's a screenshot of what it looks like. In the output, you've got the date, you've got the browser or application, you've got the file that it downloaded, and then the origin URL, so the URL that it pulled the file from. So those can be useful if you want to track to like around a time period and see what all happened on the host. For persistence on macOS, as I mentioned earlier, launch agents and launch daemons are pretty popular, but there are other places that can be used as well, like startup items. Also, there's a login item that you can use. So if you log in to macOS, you can have it run certain scripts or binaries. So you can query every login item using OSA script, ironically. You can also do a launchctl list and get a list of all the launch agents and launch daemons on the system. You can list kernel extensions, your cron jobs, etc. So those are some useful things in the area of persistence. For browser extensions, using Chrome as an example, you can iterate through the highlighted path up there and then pull the name, description, and permission data. And you can see here an example from my tool. When I ran it, it found one of my plugins, which was Wappalizer, and then it showed the permissions that Wappalizer uses. So that's something you could key in on as well if you're doing an investigation. Are there any plugins, or Chrome extensions or browser extensions that have excessive permissions? And if so, they may be a part of the infection. In terms of system information, you have your receipts and install history, so anything that's been installed by the user is tracked there. That can be useful in investigations of tracking back to what was happening around a certain time. You also have your system logs, as well as network information. And firewall rules and Etsy host can be interesting because there have been reports of real malware in the wild where once it infects a machine, it will block VirusTotal, or block Malwarebytes or different security sites. So that will be pretty interesting, as well as process information. So a few other places to look on the system for macOS. The Temp Folder, a lot of times artifacts are written there, as well as like your var folders. You can look for Etsy hosts again to look for things that are blocked. Any addition to the sudoers file, bash history. And another thing of interest is, and I've kind of played around in this space on the offensive side, is following the same approach we've seen on Windows, like migrating off of the command line and making API calls. Like, what does that look like on the macOS side? And it definitely makes detection a lot harder, but it's definitely not impossible. And one of the things you can do is you can do syscall analysis to see what the writes and reads and kind of low-level things that the binary is performing using dtruth, which is native to macOS. You can also do strings analysis. So one way I found this useful is Cody Thomas at SpectreOps wrote Bifrost recently, which is a way to perform Kerber roasting using all API calls, so not using any command line utilities. So I was just kind of wrecking my brain, like, how do you detect this? And one of the ways with strings analysis is you can see Kerber roasting and very specific strings in the binary itself. Of course, someone could pack it, obfuscate it, make that harder, but a lot of times people will just pull stuff down from GitHub and use it. So strings does have value in that space. And then, of course, behavioral analysis, like what network activity, what files are dropped, what handles are open, things like that can still be of use. So putting it all together, as I mentioned, macOS malware is becoming more relevant and prevalent today, and so I think we all are going to have to become more comfortable and more familiar with what's happening in macOS. Some simple detections may seem like they're very brittle, but I think when you have a defense in depth strategy where you have command line, you have parent-child processes, you have like least common occurrence, you've got a lot of detections at a lot of different layers. I think it will help to find a lot of different things. In terms of hardening Mac OS, some of my typical recommendations are ensuring that remote Apple events is not turned on your endpoints. Because if it is, then you can actually run Apple script on another host if you have their credentials. File sharing and SSH are turned off if you don't need those. If your IT team is performing like remote management using an account, then I'll recommend that the password be randomized and that the central management infrastructure have 2FA on it, just some simple things to protect. And then in terms of resources, again, I highly recommend the Mac Malware 2019 Objective-C report. Very valuable, lots of insight into what's going on in the wild on Mac OS. I also wrote a blog post on this content with much more detail, much more examples that you can pull from as well. Both versions of PIC, the Python one that Thomas Reed initiated, and then my Swift version. Another post that I pulled from on querying Active Directory with a Mac, so way more examples, much more in depth. And then, as I mentioned earlier, the tool to parse your browser history, so feel free to play with any of those. Questions? Yes.
This could be offensive to some, but Mac, is there any thoughts that the Mac malware, those numbers, I've seen some active campaigns going on where there's like no detections and all the detections on the Windows side and Android. Given the fact with some issues that the industry faces with virtualization of Apple hardware for research purposes without getting like blacklisted or sued by Apple. Is it perhaps that number is more of an iceberg effect? You know what I mean? Like, here's the stuff you see, and then everything down the bottom is just all the bad stuff we're not looking at. Do you think there's like a definite possibility that the industry is missing some things there?
Yeah, it could be. I think Mac is still pretty young in the detection and response space. So I think that area is new. I definitely think Macs have been targeted for a while. We're just now starting to wake up to it and realize. It's just that in most organizations, Windows is still the primary, like, makes up the lion's share of what's there. So that's where most malware is. But yeah, I think there's still. I guess I agree with you. I think there's more to it, and so I'm hoping now we can shine some light on it and kind of build up our comfort with Mac OS.
Yeah, we definitely got to start somewhere, and I think the talk is great. All those key pointers that you had in there I thought were wonderful. Just some of those other challenges you call Apple for stuff for virtualization, they turn you down. And even if you throw thousands of dollars at them, they won't help you. So
yeah,
and there's no support for it. So it's a tough world. Hopefully we can all work to make it better, and this is a great start.
Yeah, there's a lot of people doing cool stuff in the Mac OS space as well, so that can always help, just kind of meeting people, and I can give you some names of people you can collaborate with.
Hey, from the defensive side, have you gotten anywhere using file integrity monitoring to detect things?
No. Yeah, not on macOS, to be honest. I'm not really sure of any really good enterprise level ways to do that.
OS Query has it built in, but it's just a matter of figuring out if it's worth it or not.
Yeah.
Thanks.
I'd be curious if you got any ideas on it or examples, for sure. Okay, any other questions? If not, thanks. Appreciate it.